Hi, this is Mrs. Ruscio, and you are watching Key Features of Functions Day 1 Notes. In this video, we are going to have the learning goals of finding key features and identifying them, and equally as importantly, using the correct notation when writing the answers. As you can see, Graph 2 has been done for us, so we're going to be able to use that to help guide us as we answer some of these questions if needed. So let's begin. X-intercepts. X-intercepts are the places where the graph crosses the x-axis, which is here and there. And we write x-intercepts as points. So those are the points -1, 0, and 3, 0. So we're going to write those out using the correct notation. -1, 0, and 3, 0. Now, x-intercepts are very, very similar to zeros. Only zeros, we write them as x equals -1 and x equals 3. So I just wanted to show the connection between those two. They're very similar, but we write them in different ways. Zeros are the x values that cross the x-axis. Okay, let's take a look at the y-intercept. The y-intercept is also a point. It's the point on this graph where it crosses the y-axis. In this case, it's at 0, +3. Turning points are where the graph changes direction. So see how the graph goes from increasing to decreasing, it climbs, then falls. This right here, so the tops and bottoms, those are considered turning points. So we write it as a point. That's the point 1, 4. Okay, I'm going to skip right now intervals of increase and decrease, and I'm going to talk about domain next. So the domain, let's do what we've been doing. Farthest left to farthest right. So it's -2 to 3, open, close. So let's be careful with our brackets. Open, closed, equals, close brackets doesn't equal open brackets. We can also write this as inequality notation as well. Okay, the reason why I did the domain first is because the intervals of increase and decrease use the domain to help us. So it takes a domain and it breaks it into two parts, the climbing part and the dropping part, the increasing part and the decreasing part. We read a graph like we read a book. So the graph is going up over here and down over here. And notice how the turning point slices it in the middle. So the place on the x-axis that breaks it up is 1. So our graph is going up from -2 to 1 and down from 1 to 3. So increasing is from -2 to 1 and decreasing from 1 to 3. And we write those in interval notation. They also aren't as picky on a Regents exam, so we could even write that as -2 to 1 or 1 to 3 with the actual word 2 in there. Okay, let's take a look at the range, which we're used to finding. So the range is how low can you go. To remember, how high can you go? There is a point there, so that means it's closed, but notice how it starts at an open point. So that's 1, 2, 3, 4, 5, -5, 1, 2, 3, 4, +4. So my range is from -5, that's an open point, to +4, and that is a closed off point. Or we can write this as inequality notation. -5 is less than y is less than or equal to +4. Maximum and minimum values are also connected to the range. So we can get the maxes and mins very easily. The maximum value is how high the graph goes, the y value of how high it goes, which is 1, 2, 3, 4. the highest point is 4. And not a coincidence, that's the highest point in the range. So the maximum is at y is equal to 4. The minimum value, however, I'm just going to scroll up. Notice how there's an open point there? So we actually can't say it has a minimum. It gets really, really close to -5, but it never actually touches it. So I'm going to say that the minimum value is NA. It's very difficult to find on this graph. If that had been a closed point, that would have been really easy, and we could have said y is equal to 5.